Assalamualaikum warahmatullahi wabarakatuh. My name is Nurisha binti Muhammad. So now I want to discuss about question 1. So what I understand by term differentiation is differentiation is a calculus process used to find the derivative, which represents the instantaneous rate of change of a function. So differentiation have 5 techniques. First one is constant. So y equals to 8. Differentiate to differentiation dy over dx equals to 0. Second one is variable. In example, y equals to x the power of n. With differentiation to dy over dx equals to n as the power of n minus 1. The third one is bracket, which is chain rule. So y equals to a open bracket x the power of n plus x the power of n close bracket the power of k. So we differentiate to dy over dx equals to ka open bracket x the power of m plus x the power of n close bracket the power of k minus 1 open bracket m x the power of m minus 1 plus n x the power of n minus 1 close bracket. Next, uv, which is product. So the formula is dy over dx equals to uv prime plus vu prime. Lastly, u over v, which is quotient rule. The formula is dy over ds vu equals to vu prime minus uv prime over h.
So that's all from me. Thank you.
Assalamualaikum, my name is Aisyah and today I'm going to teach you question number 2 for A and B. For the first question is, find dy dx for the following function. A, 6x cubed cosecant x minus 2. As you can see here, we got two products, so we need to use product rules. Product rules stand as uv prime plus vu prime. So we need to classify it first, u as 6x cubed and u prime is 18x squared. One is cosecant x minus 2. And for the v prime is negative cosecant x minus 2 cot x minus 2. And we need to rearrange it in the formula as dy dx equals to 6x cubed multiplied with negative cosecant x minus 2 cotangent cot x minus 2. Don't forget the bracket plus cosecant x minus 2 multiplied with 18x squared. And the final answer will be negative 6x cubed cosecant x minus 2 cot tangent x minus 2 plus 18x squared cosecant x minus 2. And this is the final answer. For the second question, it's still the same. We got two products, but this time is a little bit different and we need to use quotient rules. As usual, we need to classify it first. U as 3 minus 2x, u prime as negative 2, v as secant x, and the v prime is x tangent x. And we need to rearrange it in the formula. So it will be secant x bracket negative 2 minus bracket 3 minus secant x tangent x over secant x squared. We need to expand it and it will be negative 2 secant x minus 3 secant x and x plus 2 secant x tangent x over secant x squared. And we can factorize it and it will be secant x in bracket negative 2 minus 3 tangent x plus 2 tangent x over secant x squared. And we can cancel it out like this. And it will be negative 2 minus 3 tangent x plus 2 tangent x over secant x. And it will be the final answer for this question.
Assalamualaikum, my name is Wani binti Ezian and I'm going to explain about question number 3. For the question number 3,
Given tan 3xy square plus y equals to x, find dy over dx using implicit differentiation. So for this question, we will assume the equation to the two terms, which is a and b. So I will make this tan 3 as a, and x as b. So for the a, I will rewrite this as, so we will differentiate it as usual. Okay, for the xy, we will differentiate this using the product rule, which is uv prime plus vu prime. So we need to make it one by one. So when we use the product rule, so we can differentiate all of it. So when we settle with a prime, we need to differentiate the b1. So the b1 we will get 1. So for this equation, we need to make it a new equation, which is a prime equals to b prime. So just write it all. We just need the dy over dx. So we will divide dy over dx. We will make it to the left side, and the other one on the right side. So when we divide it, we can factorize the dy over dx. So we need to remember, we just need the dy over dx. So the term that we factorized before that, we will make it to the front. So it will get the process of division. So let's just write. That is the answer for this question.
Assalamualaikum and hi. My name is Nur Ezian Sofia Binti Razi, and today I am going to do question 4. For this question, it uses linear approximation, and the question is given here. So the formula that we use here is fx approximately fx naught plus f prime x naught delta x. So from the question, we get that x value is 81.02. X equals to 81.02. The x naught value is the nearest number to the x value, so it is 81. To find delta x, the formula is x minus x naught, so 81.02 minus 81. The delta x value is 0.02. Now, to find fx naught, we must use this function here. So from the question, we get that fx equals to square root of 4x plus 1 over square root x. So from this question, substitute the value of x naught into this function. So fx naught equals to 481 plus 1 over square root of 81. So the answer is 3.111. Now to find f prime x naught value, we must first find the f prime of x. From the function of fx, we can find the prime of the function. So f prime x, x1 over 4 plus 1 x minus 1 over 2. So to differentiate the function, we must bring the power to the front and minus the power to 1. So the function is minus 3 over 4 minus 1 over 2 x minus 3 over 2. 4x cubed minus 1 over 2x cubed. Now we have that f prime x is this function. So we must substitute the x naught value into this function. So f prime x naught equals to 1 over 4. Substitute the value of x naught in 1 cube. So the answer that we got is 0.009. Now that we have the fx naught value, f prime x naught value, and delta x value, so we can substitute all this value into this formula. F 81.02 is approximately 3.111 plus 0.009 times 0.02. So the answer that we got is 3.111. That's all for me. Thank you.